Honorable
So,
members, welcome to Ujima webinar. We are privileged to have among us Mr. Sanjay Desai as the speaker from the industry. Mr. Sanjay Desai is the chairman and managing director of Free Green Excel EPC India Limited. He holds a master degree in chemical plant design from Regional Engineering College, Suratkal, Karnataka, where he also worked on 2G ethanol plant project thesis. With over 30 years of experience, he has been involved in the design and execution of ethanol and distillery plants across the globe. Under his leadership, Regreen Excel has implemented several projects based on company's in-house Emacs technology. With a focus on operational efficiency, sustainability, and compliance with zero liquid discharge norms, I invite our knowledge partner to start knowledge share. Over to you, Mr. Desai.
yeah, thank you very much, ma'am. I would like
Welcome,
to
sir.
thank GEMA, especially Dr. Jain and all the senior members of the GEMA. So I would like to also thank all of you because during all these festivities you have taken out time to attend this webinar. Thank you so much.
Thank you,
So
sir.
first of all, I would like to congratulate all the people gathered here and also those who are involved in grain ethanol manufacturing, directly or indirectly, because when we started our journey of ethanol blending 3 4 years ago, the sugar cane to ethanol or molasses to ethanol was dominating. They were doing almost 90% of the production. So now in the last 3 years itself, so now grain ethanol has become a majority. So we are able to do 70% blending as against 10% few years ago. A big congratulations to all of you. So I'd like to take 20 30 minutes for my presentation. Then another 20 30 minutes we can keep it for the question answers. So please give me a minute to share my presentation. Right now.
Sure.
So I hope you are able to see the presentation.
Yes, sir. It is visible, sir.
Yeah, today my topic chosen for this webinar is new technologies for grain ethanol production. So which is the need of the hour. Now we have jointly set up more than 200 grain ethanol plants all over India. All of you have contributed a lot in technology development, implementation, and operating this plant. But unfortunately, the assumptions which were there in the beginning of the journey, in terms of the raw material cost, in terms of the fuel cost, in terms of the manpower cost, so those assumptions are now undergone a lot of upward escalation. So the operating profit has come down by more than 50% than what was assumed. So therefore, developing new technologies, implementing new technologies, producing byproducts, improving the steam economy, water ratios, that has become more and more important. So that is the reason I've decided to take up this topic for today's presentation. So even though I'll be making a presentation, but all of you have to contribute in discussion so that all of us can, at the end of the webinar, we'll have some positive direction for further uplifting this industry. So ethanol is a molecule that is, because of this, we are here today. It has inspired a lot of people like technocrats, industry stalwarts, including the farmers and their children, because ethanol has become a revenue stream for rural India of India in the last 4 to 5 years. Almost more than 50,000 crore revenue has percolated into the farmers. So every year. So I think most of you know about our company, so I won't be explaining each slide. I will just glance through these slides. So basically, we started our journey in terms of technology development with Emacs. So every year we have come out with newer version of Emacs, Excel Maximize technology. So now we have from Emax to Emax 99. So by understanding the problems of the industry, talking to the all the technical people like you and operators, then buyers, so we always identify certain problems at every point of time. Then we try to give a technological solution from time to time. That's how these technology versions have been in place. So we have done more than 200 plants. Out of 200 plants, 132 plants are of grain distillery. So we have a very professionally managed independent director board of directors. Mr. Narendra Mohanji has joined our board of director, and Mr. Jayan Goodwale is a stalwart in the international business. He's been with us as an additional director, and there are some financial experts who are also joined our board. And we started our journey as a technocrat company. So these are our various partners and directors who are all technical people, and they every day we work as engineers and manage the projects and the business. So basically, now we have done cumulatively more than 7,000 crore business in last 5 years. On an average, we do about 1,800 crore business only in distillery and ethanol industry. So these are the plants on the left-hand side. You will see we have been involved in 207 projects. So all the growth has come in 5-6 years. So now we are also going abroad. So with Make in India equipment and technology, so we are able to convince the international market. We have quite a few ongoing projects in all 4 continents, apart from India. Then we have also developed our own capability to the dryers. We are now fabricating our 153rd dryer as of now. We have already commissioned more than 100 dryers. So we are also doing our own CPU Jaldalli plant, and we also developed in-house capability to do the engineering and project management of a biomass power for various of our project. So these are all our infrastructure. Everything is based out of Pune, but we have one facility in Ghaziabad.
आदरणीय, आपकी स्लाइड्स नहीं दिख रही हैं. आप बोल रहे हो लेकिन जो दिखा रहे हो दिख नहीं रहा है. आर यू
Yeah.
हमें
प्रेजेंटिंग?
दिख रहा है सर.
Yes.
Sir, it is visible.
हमें कुछ दिख रहा है सर स्लाइड्स.
Yeah, we all can see.
Yes, sir.
Visible. It
Okay,
is
okay.
visible. उनके सिस्टम का कुछ प्रॉब्लम है.
हो
Sir,
सकता
please
है मेरे
check your system. Please check your
ओके ओके
system.
ओके ओके
दिख
मे बी
रहा है.
आई एम हैविंग प्रॉब्लम्स. ओके ओके
Yeah.
देख रहे हैं हम.
Sorry,
देख
sir.
रहे हैं.
We can also send you later the presentation.
जी.
So if you are
क्षमा
not
करना
able to see.
क्षमा करना, मैंने आपको डिस्टर्ब किया.
Then absolutely no issue, sir. So basically, the technology has become very widespread, vast nowadays. Earlier, when we started, ethanol projects, so only converting either sugar or starch to ethanol efficiently was the technology. But later on, due to exponential growth of the ethanol industry, and also there are many inflationary cost factors like fuel cost, then water cost, and generally became the norm. So today, the whole technology development has to depend on all these 5-6 parameters, where one has to produce more and more ethanol or alcohol per ton of feedstock by maintaining the generally maintaining the low energy cost, maintaining the low water footprint. So this is a challenge. So that's where we try to also develop our own biomass power plant, our own wastewater management plant, and also we work on the electricity requirement. So it is not just that now you produce 91%, 92% fermentation efficiency, then the investor will make money. So we have to see each and every section. So that's why we call it as a Emax comprehensive technology to take care of each parameter in the operating cost cycle. So I already explained we have developed right from the Emax to Emax 99. So for the grain ethanol industry, now we are able to bring down the steam to 2.5 times. So then similarly, water also is getting reduced. Then yields are quite high. Then for molasses, we can go as low as 1.5 kg per liter. steam. So with this, you can say that, operating cost will be able to, for a greenfield plant, we can save over 2 to 3 rupees per liter. So in today's context, this is a huge improvement in the profitability. So continuously we are working on these parameters. So probably we'll further reduce all these inputs probably next year with our new technology. So these are some of the plants we have set up. We have set up 800 KL sugarcane juice plant, which operates on 600 KL on grain. We have recently taken a project for 600 KL single plant of grain ethanol plant. And these are some of the equipment, we have done in the recent past. So as you can see that, slowly and steadily, this industry is becoming economic of scale of operation. In single campus, how much more ethanol you will produce. So that decide the total cost of ethanol and also operating profitability for the investor. So that is the reason, more and more companies are trying to expand in the same campus. So we are able to cater to those needs by technology innovations. Of course, these are the few changes which have happened because of the ethanol blending policy, support from the government. One is, apart from the capacity of the plant, which has gone up, low OPEX technology requirement is there. We have to do a ZLD plant. Safety norms have changed. Because of the very high cost of manpower, people are looking at reducing the manpower through automation. Then also, many of the plants, which has to be multi-feedstock, multi-product, like you do ENA, ethanol, and some chemicals in the same campus. So these are the requirement. So basically, there are a few feedstock. I'm sure everyone is aware. One is the sugar-containing feedstock. Second is the starch-containing feedstock. Third is, of course, cellulose. Then you have 2G and 3G in cellulosic material. So basically, in India, we are familiar with sugarcane and broken rice and corn as a main feedstock for industry. Apart from this, we can also look at sweet sorghum. So sweet sorghum is a really good solution for our feedstock because today one can convert grains into ethanol and also you can convert sugar juice in the sweet sorghum juice into ethanol and you get bagasse which can be used as a fuel. So this is going to be a future feedstock. Many of the companies are now, doing a lot of field trials pan-India basis. So corn, of course, has come as a newer, game changer feedstock. So even though we have Indian corn, which is non-GMO, so we can see that, yield per hectare is going up with the aggressive farming by the farmers. So all the farmers are getting better price. So more and more corn is being produced in India. So then at the same time, corn can provide many other byproducts. We can have corn oil, we can have some better quality DDGS, then, and also the corn cob can be used as a fuel. And of course, 2G, I won't touch much because even though this was my favorite topic during my university days and also when I came to the industry, but unfortunately, cost of the plant is still very high, which is around 7 to 8 times than the 1G plant. At the same time, the operating cost also is quite high, almost 6 times the grain ethanol manufacturing operating cost. So still there are a lot of things to be done before we say that 2G is feasible. So I would say the 3G, which is from a softer cellulosic material like algal biomass, which is more soft cellulose. So this may be tried out in India. So because being a tropical country, we have a lot of sunlight. One can definitely grow algae in masses. And CO2 from the 1G plant can also be used for growing the algae. That is another advantage we have. So I hope, sweet sorghum and algal mass, these will be the future feedstock to consider for the R&D and the technology development. So So basically, this is on the right hand side, you will see that, we have achieved close to 20% and we can go up to 30% by 2030. That is a prediction. Then there are a lot of negativity due to the blending of the ethanol E20 in the media, social media. So these are the, facts in terms of the octane numbers, how efficient is the ethanol blended fuel. So this chart illustrates that. So one need not worry about the efficiency of the ethanol usage in terms of the mileage, also in terms of the maintenance of the vehicle. So today, if you see in Brazil, they are successfully doing E27 plus or minus 3. That means when they have excess ethanol, they do 30% blending. When they don't have much ethanol, that time they restrict themselves to 24. This is already proven. All the automobiles, various models have been using these kinds of very high blend of ethanol. So, like I said, now instead of sugar, grain ethanol has become a majority. Now the sugar has become only less than 30%. So this slide illustrates that how the shift has taken place from sugar industry to grain industry in terms of feedstock to feedstock conversion. So nowadays we have seen that because of the government policies, because government want to provide 40% rise from the FCI, remaining DFG or maize for the industry, and also there are a lot of companies who are having molasses or sugarcane. So multi feedstock is becoming a norm in many places like Karnataka, UP, and Maharashtra, where you have sugarcane, where also you have grain. So at the same time, many companies are also looking at producing ENA in the same plant, apart from ethanol. So depending on the permissions that you have obtained, so one can always think of doing ENA and chemical grade alcohol, ethyl acetate, butyl acetate. When after doing a proper market research, so one can also look at producing these uh, chemicals in the same complex. So that's why we always design the plant with the flexibility that in future you can either add ENA or you can add some chemical manufacturing unit or you can add different feedstock. So each plant based on Emacs are flexible to add any of the feedstock, any of the products in future. So basically, now everyone knows about the 1G technology. Basically, you have a dry milling, then you have liquefaction, then fermentation, distillation, and ethanol dehydration. Then you have a decantation followed by evaporator and dryer. This is the standard technology that has been implemented. So, and most of you have the dryer integration where the dryer energy is used for running the evaporator. So this is the configuration we have. But in order to exploit, the better value of the feedstock, one can think of many various, the technologies or add-on technologies to improve the profitability. One is, of course, the differential milling technology, which is called as a selective milling, where one can access more starch to produce more of ethanol. So at the same time, you can separate the fiber, then that fiber can be added back into the DDGS to get a better value for DDGS. So this is one technology. Second is a 1.5G technology. Some of the fiber that are separated can be converted to ethanol. So apart from the starch to ethanol, you get a higher yield through this fiber conversion. Then corn oil separation, I think many of you already implemented this system. So one can separate corn oil at different places in the distillery, and each scheme has its own feasibility in terms of how much oil you will get and what is the cost. Then protein enhancement. Sorry for the spelling mistake. So protein enhancement through solid state fermentation. So this is another technology which is being talked about. So once you do the distillation and we have the wet cake and syrup, so that can be subjected to solid state fermentation by adding some inoculum. to increase the protein content of the DDGS. So this is similar to what they do sometimes in the soya industry. Then next one is maximum water recycle through MBR technology, membrane buoy reactor. So from the current anaerobic and RO system, so further if you add membrane buoy reactors, you can further improve the quality of water and also reduce the reject quantity. So water conservation through air-cooled condenser, then heat pump technology, which is MER. So with this, you can recover a lot of waste heat and recycle back to the system to reduce the steam consumption. So many of you have biomass power. Some people have, the fossil fuel coal-based power plant to support the ethanol industry. Here, one can develop power plant technology or the equipment to handle any kind of biomass like corn cob, cotton stack, even the bamboo, mustard, soyas, so that your fuel cost can be lower and also you contribute in achieving the net carbon zero by not touching the coal. And the last one is biogas generation from grain ethanol plant. So there are many streams which has high COD, BOD in the grain ethanol. One is of course process condensate, spent leaves, floor washing. Apart from this, one can also look at feasibility of conversion of the syrup to CBG rather than mixing it back to the dryer. So of course you need to see how much revenue you get from CBG and how much loss will be there because of protein loss in the DDGS. So these are the things, but definitely one can look at this option. This is technically feasible. So I'll go into a little bit of detailing. These are some of the pictures from the American plants. So differential milling, basically, once you have the slurry, then you use paddle screen, which are shown in the bottom. These are high rotating paddles inside. Then at the end, there is a screen. So it will work like a centrifugal machine, decanter, but it has got paddles inside instead of the scroll. So one can always separate, fiber from the starch, and the starch can go to the grind mill. Further grinding will happen. Then your liquefaction can continue. With this, we'll have separated the fiber effectively. Then more and more starch particles are subjected to the action by the enzymes in the liquefaction. So your liquefaction enzyme efficiency will be higher. And some part of the fiber also is coming into liquefaction, so that will also get converted into ethanol by using a different enzymes in that. So this is a technology which is already implemented in USA. So this can be, thought in Indian context also. Then you also have, once you have the fiber separation from the earlier method, one can also look at, recycling back the fiber, subject to fiber to ethanol conversion technology. Here, you need a little bit of 2G enzymes. So we also need high temperature pressure. So that's why on the right-hand side, you will see a picture, which is basically an autoclave reactor. Something very similar to a bigger 2G reactor, but it is a smaller and a low capex, low opex reactor. So our aim is only to separate fiber. So with this, these two technologies combined, one can look at increasing the ethanol yield by 8 to 10%. Supposing you are getting 380 liters, so one can think of getting almost 415 to 420 liters. Then corn oil recovery also will improve because you are separating the germ very effectively in the differential milling machine. Then dryer, of course, energy will naturally will reduce because you are not putting so much of fiber. Some of the fiber is converted to ethanol. So of course, corn oil separation is another byproduct which one can look at. So these are the corn oil samples. Of course, today ethically corn oil has to go for biodiesel because we are separating the corn oil from either a tricanter or a decanter separator after the process. Only when you separate the corn oil before the liquefaction by using a dry milling, germ separator, then only it can go for edible purpose. Otherwise, once this is processed through liquefaction, fermentation, distillation, then ethically it should not be blended with the edible oil. So chemical composition wise, it will have more impurities. So therefore, since we are having a technology to separate the corn oil after the distillation, we always recommend that they should be sent it to the biodiesel industry as a feed. So today there are two methods. One is after distillation analyzer column. Before the decanter, one can have a decanter separator to separate the corn oil. So where you need some emulsifier for this. So then the only thing, the corn oil separation will be quantity wise, it will be higher. We can get almost for 100 kl plant, you can get 6 kl in this system. Then decanter onwards, the process remains the same. Then depending on the DDGS requirement in terms of the oil and fat, so one can always decide how much corn oil to separate and how much to leave in the further process so that DDGS will have required oil and fat composition. The second method is, the after the evaporation, before the syrup goes to the dryer, so one can put a same decanter machine, separator machine. So there you can separate the corn oil also. But here the quantity of the corn oil will be less. It will be roughly half of what it would have been when we do the first process. So because whatever oil is coming in the thin slope, only that is coming into the evaporator. Whatever the corn oil that is going in the wet cake, that remains same. So this is another method. So we have developed a single machine which can be used for either of these application along with alpha level. So only thing when you use the machine at the single machine at the evaporator syrup line, so the same machine is used for analyzer column bottom, then the capacity will be half. So this is the only point you have to consider, and the oil recovery will be also half. So protein enhancement can be done. Basically, it is a very simple process. Once you have wet cake and syrup from the high mixer, you take it to a diffuser trough where aeration is being done, and the whole wet mass moves from one side to another side. We need about 6 to 8 hours retention time. Then you add some special yeast strain with some nutrients. So you can actually, the yeast and the bacterial strain will grow on the wet cake and the syrup. Then it will, at the end of the 6 to 8 hours, it will go to the dormant state. So where it releases a lot of protein from the cell walls. So that's how you can increase the protein content by 10 to 15%. So this is tried in many countries in abroad. So we are also developing this technology and the equipment so that the protein content of DDGS produced from corn will be higher, texture will improve. Then also we also hope that aflatoxin also levels will come down because some of these fungal affected mass in the DDGS will be consumed by the inoculum. So that will make it as a good DDGS at the end of the cycle. And apart from this, we have water recycle. This is a typical membrane bioreactor. So these are like ultrafiltration. These are a fit and forget kind of a membrane. So after the anaerobic digester for CPO, one can do a little bit of variation. We can pass the treated anaerobic treated water through this membrane. So this will produce very good quality output water, which can be recycled to fermentation. So that's how we can look at almost 95 to 97% recovery, and your reject will be much less. So this is a typical scheme of that. So, and of course, today the challenge is to use this water from CPU to the fermentation. So with this proper operation of these system, one can always look at, using maximum water into fermentation. Then to reduce the reject or to take care of the reject, one can also use ATFD, acetilated thin film dryers, to make it as a salt instead of the liquid discharge. Then, of course, air-cooled condenser, most of you already aware. So if the air-cooled condenser are used properly, so at the various places, especially evaporator, so then one can reap the benefit of air-cooled condenser with low power consumption and also the less water requirement. If you try to be very aggressive and use it everywhere just for the sake of using it on every alcohol vapor, then the power consumption will go up, and you will not achieve the so much of water saving as compared to the power consumption and the cost of the air cooled. So we always recommend that air cooled condenser should be used only for evaporator, not for the alcohol vapors. Also, risk of losing alcohol also is not there when you use it for the operators. So the latest one is the heat pump. So basically, heat pump or MER is a compressor. So this is a typical illustration of the technique by which one can recycle the energy back to the system. So this is a single effect evaporator where during startup you add steam, then the steam will evaporate and produce water vapor. That water vapor, once they are generated, you can connect to the section of the compressor. Then this will compress or increase the temperature by 8 degrees. Then that can be used as a steam once the plant is stabilized in few hours. So this will help to make the steam consumption zero for your operator. Also for running the distillation, one can use these heat pumps. So only here again challenge is if you use these pumps not efficiently, if you go very aggressive, then the power consumption go up. So one has to be very careful about where to incorporate these heat pumps. So because that will decide both the capex and opex. So in our system, for a greenfield plant, when we bring down the steam consumption from 4 to 2.5 kg, so we don't take any extra power. In the same power, we can connect the heat pumps and still reduce the steam consumption. That is our specialty of the technology, what we have developed. And at the same time, for a greenfield plant, the capex will not go up. So whatever saving we are achieving in the boiler, capacity, also in the cooling tower capacity. So within the same capex, one can add 3 to 4 heat pumps. So that is how we have integrated this system. So we are already doing about more than 25 projects based on this technology. So as big as 600 KL, we are doing this technology. So this is a typical scheme. So basically, in the operator is very simple. All the standalone operators can be, run on heat pumps. Only startup we need steam. But apart from this, in the dryer, we have a lot of extra energy. When you connect the dryer vapor directly to the evaporator, then we'll not be able to recover 100% of the energy because the dew point of the vapor, there is almost 30 to 40% air is in the dryer vapor. So that will not allow you to recover all the heat. So dew point of 85 degrees, so that decides how much condensation will happen in the evaporator. Whereas when we connect heat pump, so this is increasing the temperature of the vapor. So your dew point also gets shifted. So you can hope to get more and more energy recovery. So we can even use it for running the distillation columns or even heating the liquefaction. So with this facility. So that's how the steam consumption will be reduced using this. Like I said, when we integrate the heat pumps, so we don't increase the power consumption. So same time we don't increase the capex. So for a greenfield plant, for a brownfield existing plant, so we can always look at expanding. If I save say 10 ton steam from the existing plant, so the same 10 ton steam can be used for increasing the capacity of the plant. So that way, the heat pump will be more effective for existing plant. So apart from the process plant and the water management, we also developed a lot of schemes and the combustion technology and engineering for using a lot of waste agriculture biomass. This is the typical Lambian reciprocating grade, which can be used for burning any kind of biomass, including the RDF, including the plastic waste. A lot of these things can be burnt. So we can also have a combination of various biomass like cotton stack, corn cob, mustard, rice husk in this grade. So a lot of these plants have been set up in Rajasthan and Madhya Pradesh in UP. Then a plant was set up in Assam to burn the bamboo. So Mr. Samarth of Seas Biotech is a pioneer in this bamboo fired boiler designs. So along with him, we have implemented one project. So basically, apart from helping net carbon zero, so all these locally available biomass are cheaper as compared to coal. So your cost of steam or fuel is very, very low. These are some of the data. And apart from this, in Excel, we have developed the CBG technology mainly for Napier grass. So where it is more cost effective and also in terms of operating costs, it is much lower than what present technology is. So with this experience, one can also think of developing a core CBG production with ethanol production, so including the conversion of the syrup to CBG. Because everyone knows that the biggest enemy for DDGS quality is the syrup. So because it has got less protein, it spoils the DDGS quality in terms of the texture of the DDGS, color of the DDGS gets affected because of the syrup. So one can separate out the syrup to large extent and convert that into valuable CBG. That CBG or a biogas can be used in the existing boiler, or you can also develop a CBG business for that. So technically, the DDGS quality will improve. One should get better price for DDGS. So that in future we have to evaluate the feasibility, because right now since the DDGS quantity is quite high all over India. So even if I remove the syrup, the DDGS price remains the same, but technically it should go up. So in the past it used to go up. So after probably 1 year, once the DDGS market stabilizes, so one can think of doing this CBG in the same plant. Of course, if somebody wants to expand without adding a dryer or without adding a new boiler turbine, so 30-40% expansion can be thought of by just adding few fermenters and a CBG plant. So because the same dryer, when you remove when you remove syrup, can give you higher capacity. So, so with some 20%, 25% capex, you can get 30 to 40% increase in the capacity with this method. And your fuel costs remain the same because all the gas can go to the boiler. So this is one scheme we are working on. We are working with all the quite a few customers to establish the feasibility, commercial feasibility first. And then we hope next month onwards we'll start implementing few projects on this. So these are some of the plant setup by us. So we also do a lot of CSR work, like every corporate does, including yourself. So these are all happy customers. So these are plants we set up in other countries, where apart from the ethanol, we have set up plants for producing European grade alcohol, ENA, and also in Mexico, we are setting up a plant for meeting the US requirement of ENA quality based on grain. So thank you very much, sir. Thank you for this opportunity. So I think now we can invite some question and answers.
The session is now open for questions. Please feel free to ask yours.
Good evening. This is Shivakumar from Sri Lanka.
Good evening, sir.
Yeah. You just told that the air-cooled condenser you can use only for evaporator, not for distillation. Can I know the reason?
See, so basically one can use the air-cooled condenser for distillation also. So, but only thing effectiveness of air-cooled condenser will be much more if you use in the on the water vapor, because water vapor it is very easy to condense. It is not volatile. So then the temperatures are quite high. So supposing you have say 45 degrees worst case, the ambient temperature, the water vapor is always above 55, 60 degrees at the evaporator. Then you can design the air-cooled condenser cost effectively. Your cost will not go up. At the same time, if the air-cooled condenser is smaller, your power consumption also goes down. Supposing if you have to design the air-cooled condenser for alcohol vapor, so which is normally in the multi-pressure plant, it is at 50 degrees. And at 45 degrees ambient temperature and designing at 50 degrees, the size of the air-cooled condenser goes up like anything. Then, your power consumption goes up. So that is what I meant. For a designer, both, situations are okay. But only in terms of the cost effectiveness, I would suggest you go with only, on the evaporators. Even in the integrated evaporator or dryer integrated evaporator or a standalone evaporator, you can go. And you will save much more water in those condensers because heat is much higher. Whereas in alcohol vapors, since in multi-pressure, you always use that alcohol vapor in driving another column or a reboiler. So you may not require too many, air-cooled condensers over there.
Okay, understood. Thank you.
Yeah.
Sanjay, good evening.
Good evening, sir.
My question is like in the last slide for CBG plant, you have mentioned that we are taking the syrup from the existing plant to the we are taking that syrup from the existing plant and not giving it to the dryer. So what will be the protein effect on the running DDGs?
Yeah, basically, sir, today syrup has around 80 to 90,000 COD, ppm COD. So that can be converted to the gas. This gas you can either burn in the boiler, reduce the fuel consumption, or you can bottle it and put it in the cascade and sell as a CBG. Both options. Of course, you need some napier grass or cow dung supporting for this. So this is technically this is already proven. And once you remove syrup that is going into the dryer, so of course you need to leave a little bit more moisture in your wet cake, because only at 30% wet cake then you will have some charring. So you need to lower. You can adjust the decanter and you can lower the solid content in the wet cake coming out of the decanter. So, but how much you will lose in the DDGS, because DDGS tonnage will go down because you are not adding the. But all over the world, once you remove the syrup, the DDGS price will go up. So your color will be better, your protein content will go up,
Okay.
and texture will. But here in India, unless that is established, it's very difficult to establish the feasibility. So right now, if you take the same price of the DDGS, so it may work out a little bit increase revenue for the CBG, but not much.
All right. Thank you. What's the protein?
Sanjay ji, Sujit Srivastava here from HML Bhatinda.
Yes, sir.
Sir, you have shown in your diagram that vapor from the dryer, you are using heat pump and heating the distillation. So, is it that 100% dryer vapor can be utilized here or partial?
Yeah, so with adding MERs in series, so you are increasing the dew point of the vapor. So that way, one can hope that at least 90% of the energy recovery will be there. It is very difficult to achieve 100%. So, but right now, by just directly connecting to a operator, we are only able to recover about 60% of the energy. With this heat pump, with the help of the heat pumps, we can increase it further. But achieving 100% would be difficult, sir.
So up to 90% can be achieved, can be
Yes,
recovered.
yes, sir.
Okay, thank you.
Yeah. Here, one care we have to take is, as it is in the distillation, one cannot use. You need to see the temperature gradient. So you need to probably have columns under vacuum. Yeah.
Yeah, definitely some columns are in vacuum, but in liquefaction can be used because it will not disturb the distillation.
Yeah, only the layout wise, it has to be near the dryer liquefaction. If it is more than, say, 20 meters, then there will be condensation in the vapor line of the dryer vapor. So, but otherwise you have to just use for heating the water in the hot water tank, and also you can use that energy for boiler water heating. So basically, the heat pump will only produce a high pressure, water vapor, so that you can use for any of your heating purpose, not only for distillation or for the liquefaction. So wherever you need in the whole campus, wherever you need high temperature water, you can use this. Yeah.
Okay, thank you, sir.
Any other questions from the member side?
Sanjay sir, Shumakoshi this side. Can you please explain some protein enhancement through solid state fermentation? Elaborate something.
Yeah, basically, those who are familiar with sugar industry, we use equipment called diffuser. So where the sugar cane is, crushed and you make a lot of fiber, then it will move from one side to another side where you keep recycling the water. So similar equipment, we call it as a diffuser. Then you have aeration at the bottom and, throughout the length of the equipment. So then you add some bacterial inoculum and yeast. The yeast which is used for producing you can call it as a simple baker yeast, not alcohol producing yeast. So that yeast will consume all the fiber and other impurities, and it will produce basically the protein, because yeast cell wall has a lot of protein. So at the end of the cycle, when yeast goes or a bacterial strain goes dormant or a yeast dies, it will release a lot of protein. So that is how it helps in increasing the protein content. Then the rest of the drying process remains same. Just you take wet cake and the syrup mix, then you pass through this equipment with the aeration at the bottom. Then it moves from one side to another side. You need a retention time of about 6 to 8 hours. So then at the end of the cycle, you will have, a better quality DDGS when it is dried, of course. So because drying will not happen in this equipment, drying will have to happen in the dryer, standard dryer.
So
Yeah.
this will be happen after spent wash, on spent wash.
No, after the wet cake and the syrup. So after the high-speed mixer. So you are just introducing this equipment between the decanter and the dryer.
Okay.
Yeah.
Thank you.
Yeah. Thank you.
Hello, Sanjay.
Yes, sir.
Yeah, this CO2 which is generated during fermentation, can we get converted into ethanol?
Yeah, CO2 ethanol, there are some technologies, fermentation technologies are available. You need a lot of
Okay.
hydrogen. So that hydrogen can also be produced from your water in the, distillery. But only thing for production of hydrogen, 1 kg you need 52 kW of, power. So then this hydrogen CO2 with gaseous fermentation, one can look at producing the challenge is not this fermentation or production. Challenge is how do you generate low cost hydrogen? So that is a challenge.
Okay.
Yeah. Then of course CO2, the easiest way is to produce methanol from you can go with there are some chemical reaction, high temperature, high pressure with zinc copper reactors.
Yeah,
Yes.
catalyst.
Yeah. So again, there also you need hydrogen, but not so much. So because methanol require less hydrogen as compared to ethanol.
Okay.
One can you also need little bit of carbon monoxide CO that can be produced from burning the biomass.
Mhm.
So then again, methanol has a ready market because all the shipping lines they want to use methanol mix in the diesel or marine fuel.
Okay.
That way, one can think of producing methanol.
Mhm. And regarding this, your oil from corn oil, what is the market for that?
See, biodiesel industry is actually starving for feed. So everywhere they have set up biodiesel based on jatropha or the waste cooking oil or any other oil, cottonseed oil. But none of them are receiving even 30% of the feedstock. Then using edible oil, palm oil, and many other is not feasible. So you can, if you have a say 400 KL plant or 500 KL plant like what we have, so you can produce roughly around 20 or 25 KL corn oil. Then you will get about 10 to 12 KL biodiesel. You can even establish your own biodiesel plant, or you can sell this to biodiesel factory which is having 10 to 15 KL per day capacity. So that is a possibility. So I think they are paying around 65 rupees maximum per liter of corn oil.
Okay.
But of course, the challenge what you have is the DDGS buyers are not accepting that you reduce.
Accepting, yes, that is the main issue.
Yeah.
De-oil DDGs, they are not giving
Yeah.
less price.
Yeah.
Okay, thank you.
Yeah. Thank you.
Hello.
Yes, sir.
Sir, is there any possibility of getting ethanol from Tapioca starch, sir?
Yeah. If you see in Thailand, almost 50% of the ethanol produced is coming from Tapioca. Then also, few factories are there in Indonesia. So
Okay.
it is a very well established process and the business. So we are involved in a 400 KL plant in Thailand where they do tapioca. So they have two different systems. One is for dry tapioca chips. The milling remains the same in that case, except some sand suppression. You receive a lot
Okay.
of mud from tapioca, so you need to be very careful. This is one. And you have when it is dried, you have 70% starch, and you get more than rice, almost 480 liters of ethanol. So, but drying a very large quantity of tapioca is very challenging. So that's why they also most of the time use wet tubers. So for wet tubers, they have to go with wet milling. Then lot of these centrifuges, then they make a starch slurry, then they use it. It's a very cumbersome process, so a lot of capex and operating costs is required. But in Thailand, since the tapioca is very cheap, so they are able to do that.
Sir, what cost Tapioca based ethanol? What cost they will buy, sir?
They are buying, I think, see less than when you convert that into dry form, they are getting 15,000 a ton, and they get almost close to 500 liters. But of course, another challenge is there is no protein in that, so you have to necessarily do biodigester, then aeration. So in those countries, it is allowed to discharge after certain COD BOD level reduction. So you get some biogas, but that is also not very high. So unless 15,000 a ton, dry tuber is there, this is not feasible in Indian context.
In South, it is available in lot quantities, sir.
Yes, sir. In
In
Salem
bulk
area,
quantity.
I'm sure it is available. Yeah.
Yeah, here it is available, sir.
Yes, sir.
Here it is available. Is it possible to extract from the grain-based ethanol plant from if you are sending Tapioca dried roots, dried chips, sir, dried chips from here?
Yeah. Only the initial sand separation or mud separation, once it is dried, so we need to have some sort of a bigger destoner for these dry chips. So once that is done, then you can send it to the same mill. There is no change. Liquefaction, fermentation, nothing. There is no change. So only the after decanter, the solid content is very low. So evaporator will not be very cost effective. Then you have to do a biogas in that.
What price government will buy, sir? If it is Tapioca-based ethanol?
I think Gemma will know. I don't know whether there is any separate price fixed for Tapioca. Yeah.
Okay, sir. Thank you very much, sir. Thank you.
Hello, good evening, sir. This is Neeraj Pratapmal from Kripco Green Energy Private Limited, Surat, Gujarat.
Yes, sir.
Sir, you talk about the selective milling technology. So what they are doing for the residual starch, which is going out from the fibers content? What is the process to recover the residual starch, which may going through the fibers content? Thank you.
It's a very good question. The first challenge is to separate the fiber. That is done in the selective milling. So there you get more starch separated. Germ is separated, fiber is separated, and more starch is separated from all this fiber, which is sticking to fiber and germ. So that means you get about 2 to 3% more ethanol once the starch slurry is made. So that is one. So whatever is leftover residual starch along with the fiber. So supposing if you go with 1.5G technology, where that whatever starch is going along with fiber, that is very easily converted to alcohol. Then if you add 1.5G, the strains, the cellulose strains, then you can recover some of the alcohol from the fiber, convert some of the alcohol from the fiber also. So there are two steps. One is a selective milling that only separates and make more starch available for the liquefaction. Then the second step is go with the fiber conversion to ethanol. That's where whatever residual starch has gone, that will be converted.
Okay, sir. Thank you.
Yeah, thank you.
Sir, can you explain, sir, 1.5G technology, please?
Yeah, basically, see, fiber has a softer cellulose. And the earlier gentleman asked me the residual starch, some residual starch may go along with the fiber when you separate in the selective milling.
Yes, sir.
So basically, we have to adopt a 1.5G technology, cellulosic enzyme. So when we call a 2G technology, where native raw material has cellulose as a core, then you have hemicellulose, you have lignin. So first we have to separate in a 2G in agriculture residue, say for example rice straw. So you have to separate the lignin, you have to separate hemicellulose, then you convert the cellulose. So that cost is very high. Whereas in this 1.5G technology, you have only the fiber. It doesn't have a lot of hemicellulose. It doesn't have any lignin. So converting that fiber cellulose into alcohol is much easier, much cost effective by using the cellulose enzymes. Yeah. So you have to add back that into fermentation. Once you do all the conversion, you will add back into the fermentation because you are converting that fiber cellulose into sugar, and sugar, C5, C6 sugar will be converted along with your liquefied dextrins in the same fermentation. Yeah, so you expect to get about because fiber content in the corn is 10 to 12%. So right now I do not have the actual conversion, stoichiometric calculations, but roughly you get about 20 to 30 liters more ethanol with this 1.5G technology.
Okay, sir. Thank you.
Yeah.
So any other questions? Since there is no more questions from the member side, let us conclude the webinar. So we are very thankful to Mr. Sanjay Desai, sir, as a valuable knowledge partner. Please accept a token of appreciation from JIMA.
Thank you so much, ma'am.
Thank you, sir. Thank you once again. Thank you all for your valuable time and participation. Good evening, everyone.
Yeah, thank you all, sir. So you all have my contact number. Anytime you have any questions, so you can always, disturb me. Yeah. Thank you so much, sir.
Thank you.
Thank you.
Thank
Bye-bye.
you, sir.
Thank you, sir. Thank you, everyone.
Yes, sir.
Yes, sir. You पूछ रहे थे?
कहाँ है भाई क्लोज कहाँ? Thank you so much, sir.